What's up? I'm Troubleshoot. Welcome back to another video. In this quick guide, I'll be showing you how to control the fans in your computer through software. Previously, this wasn't really possible unless you buy physical fan controllers and download software like Corsair IQ, etc. But somewhat recently, with an open source free piece of software, you can control pretty much all of the fans on your system in just one simple app. It's super powerful and great if you're trying to minimize noise from a PC like I am. This video is going to cover the software from start to finish. As long as your fans are plugged directly into your motherboard, it's more than likely that you can control all of them. On top of this, there are third-party extensions to work with certain controllers and other gadgets and devices. Anyways, the software I'm going to be showing you is FanControl. As you can see over here, you can set up graphs for different temperatures to control your fans, and I've set up mine to be my CPU radiator, back fan, front fans, bottom fan, etc. And I can control all of these individually with great accuracy. This is a super cool, very powerful piece of software, especially if you're trying to minimize noise from your system. Anyways, without getting too advanced, let's start off fresh. Where do we download FanControl? Well, you'll find a link to GitHub. Don't worry, it's super simple. All you need to do is, once you get to this page, look for, over here, download the latest archive. Simply download it, and you'll have a zip that you can simply open and extract to a folder where you won't be deleting it. So for example, I'll place it maybe not on my desktop, but documents or something like that, so they're not deleted accidentally later on. For now, I'll just make a folder on my desktop as an example. Imagine this in your documents or something like that. Anyways, all we need to do is drag all of the files from our zip into our folder here, and once it's extracted, we can delete the zip. Then we have fancontrol.exe. Simply open this, and the software should start. If you have Scoop installed, you can run these two commands to install FanControl. If you have Scoop and use this method, you can simply hit start, and you'll find FanControl on your start menu. Very easy to get to. This is my preferred method, and if you'd like to install Scoop, simply click this link here, then click Scoop in the top left, and we'll get these two lines to install it. Simply open up a new PowerShell window by hitting start and typing in PowerShell, or opening Terminal if you have it installed, and then make sure that PowerShell is open. Otherwise, click the drop down in Terminal and choose Windows PowerShell. Once you have Windows PowerShell open, copy the first line as such, paste it in, and hit enter. Then copy the second command, once again paste and enter to install Scoop. Once Scoop is done installing, you can run the two commands here from the FanControl site in order to install FanControl. So first it'll install the extras, then it'll install FanControl, copy and paste, and just like that, everything will be set up done. Now, you can either start it from your start menu if you installed it with Scoop, otherwise open up the folder where you extracted it to, and you'll find fancontrol.exe. I'd recommend making a shortcut with right click and, in my case, more options, create shortcut. Then I'll name it simply FanControl and move it to my desktop for easy access later on. There we go. I've got the FanControl folder where I'll leave it wherever it is, documents, etc., and the FanControl shortcut. Opening up FanControl for the first time, you'll see something like this. All we need to do is click OK, then yes, and it'll detect all of the different fans that we can control in our PC, as well as the start and stop threshold, at what percent they start moving or stop moving. Then it'll help us name and identify them to make it a bit easier to manage. Simply choose yes, and when you see this pop up, you can choose what sensors you'd like to monitor and control your fans with. More than likely, it'll just be CPU, GPU, and maybe motherboard, but there are other options here that you can tick, such as Corsair power supplies, etc. For me, I'll just hit OK, and it'll start pairing with our computer. At this stage, you'll hear all of your fans speed up to 60%, and it'll slowly raise and lower the speed of one fan at a time until it identifies all of them, as well as how controllable they really are. We'll test number 1, 2, etc. This could take a few minutes depending on how many fans you have in your system. Eventually, it'll get to controlling your fans in your graphics card, and finally, after it identifies or at least tests to see which fans are controllable, it'll start testing the start and stop percentages at which the fan blades stop spinning or of course start spinning. This will take also a while as it slowly ramps down the speed to find out when they stop spinning. It's a good idea not to have anything in the background that'll eat away at your PC's temperature, causing certain bits to overheat and possibly throttle, such as games, etc. Just have this program open. Then it'll start to see what percentages they start spinning at. Now we have a whole bunch of different options here, and all of our fans ramp up to 50%. This is where we'll be identifying them and labeling them for ease of use. For this, I'd recommend turning off one of your fans, then physically looking at your PC and finding out which fans are no longer spinning as soon as the RPM reaches 0 or at least near 0. There we go. Now have a look in your case and see which fan is currently not spinning. For me, I'll say it's the back fan. Then you can raise it up just to make sure that adequate airflow is in your system. Then we'll go down to fan number 2. Once again, stop this or possibly even raise it, depending on which way you think will be easier to spot which fan is which. You can go nuclear and turn off all of your fans in your PC, then simply enable just one of them, and it'll be super easy to see which one is spinning or at least speeding up and which ones aren't spinning at all or slowing down. Finally, after labeling all of your different fans, so for example, back, front, radiator, etc., you'll be able to click OK. But keep in mind, sometimes if you have a radiator and pump combo, to water cool your PC, the pump preferably will be plugged into a pump header in your motherboard, meaning that it runs at a solid 80 or 100% all the time. If, for some reason, you find that one of these isn't doing anything, but it's reporting that it's spinning faster and slower, that could be your water cooling block. For this, it's always a good idea to make sure that it's setting it around maybe 75 or higher percentages, or at least until it starts making noise. This we'll get to later on, so as an example, I'll name this one AIO pump. Usually though, you won't have this as an option, as your pump will be controlled either by a separate physical controller, or it'll be plugged into a pump header where it's set to always run at 100% or something along those lines, but you can usually adjust that in BIOS. I'll click OK, and then we'll get some final few options. Definitely start this with log on and start minimized. That way, it'll appear in your taskbar in the bottom right. Finally, we can hide the redundant RPM speed section, which is the section over here telling us the speeds of all of our fans. Why is this? Well, it's already covered in the top section here under controls. Alright, now that we've labeled all of our different fans, let's get to controlling them. What do we usually need to control fans with? Well, temperature. So, at the bottom, we have curves. Currently, we have a flat curve, as in just a set number. This is set to 50% speed. I can control my back fan, for example, by either clicking the 3 dots and choosing manual control, then enabling it and dragging this to a certain speed. This will set a certain speed, tell us the RPM, and that's it. If you'd like to control it from a curve, simply disable manual control and choose the curve here. Just like that, it should be set to 50%, and that's that. We can add multiple fans to the same curve so that we can control multiple fans just by changing a number. For example, changing this to 30 changes both my front and back fans. Let's get a bit more advanced. If I choose the plus button, we have multiple options here. On the left, we have sensors, so we can combine multiple sensors, for example, to get an average speed across multiple components, such as maybe a CPU, graphics card, etc. On the right, we have all of these options here, which are curves. We have an auto fan curve, sync, flat, trigger, mix, graph, and linear. Let's start with the simplest, being linear. All we need to do is choose a temperature source, which is a common factor for pretty much all of these on the far right, except for flat, that's just a single number. For linear, I'll choose a temperature source of, expanding into all of these options, one of my cores on my CPU, or the CPU package, possibly the core max, as in the hottest core in my CPU, core average, and maybe a temperature on my motherboard if this is enabled, and something your motherboard reports, or maybe even your graphics card temperature. Let's set it to the max core temperature in my CPU. That way, all cores should be adequately cooled, not just the average if one core is getting really hot. Now, you can see that as the temperature rises, so does the percentage here, and the same goes for a dropping temperature. If we expand it, we have a bunch of options here, such as a minimum and maximum temperature, minimum and maximum speed, as well as hysteresis, which we can enter a number in, either positive or negative, for which the temperature must change in the given response time in order for the fan to change value. So, if it only changes by 1 degree over 1 second, the fan speed won't change. But if it changes more than 2 degrees over 1 second, the fan speed will change. This option isn't really important for now. We'll mainly focus on these ones above it, if not none of them. Linear is simple, but you'd want something with more control. So I'll delete this and we'll add a graph fan curve. Then we'll select something like maybe my graphics card, and we can see a graph of speed versus temperature. If we click edit here, it pops up a new graph where we can control fan speed on the left side here and temperature on the bottom. All we need to do is grab these points and adjust them. You can also change the graph down here to be a minimum and maximum. I'll set the maximum to around maybe 90 degrees, as it usually won't get hotter than that before thermal throttling. If I were to leave it like this, it'd start at 0 fan speed at 20 degrees and slowly move up all the way up to 100% fan speed for 80 degrees and above. We can add more points simply by clicking and dragging, just like this. We can get super fine with our control. Also, we can right-click points to delete them. You can add as many or as few of these as you'd like. Where exactly do you place these? Well, let's start off simple. Where do you want your fans to stop? Let's say you don't want the fans running at all at 30 degrees. Simply just drag it across like this. Then you don't want your components getting hotter than maybe 75 degrees, so you'll either drag this point to roughly 75, or you can select the point and type in 75 manually here, then 100 fan speed, click anywhere else, and the numbers should change. The dot should also move. Now, to get more controlled, let's say our fans start getting noisy at around 40%. What we can do is make it dot somewhere around 40% and say I'm only really okay with fan noise when my PC is hotter than maybe, I don't know, 70 degrees. So we'll place a dot at 70 and 40%. Let's say that below 30% fan speed, my fans are practically dead quiet, so they can either be running all the time or not. It really wouldn't faze me. Usually I'd recommend to leave fans on longer than not, just to make sure everything's adequately cooled. So let's say anywhere from maybe 50 degrees, it should be at around 30%, otherwise dead quiet. Or maybe we could do something a bit more drastic, where the fans run at their pretty much dead quiet speed all the time from 30 degrees and above, and slowly ramp up to where they just start making noise at 70 degrees, and then they can max out all the way, maybe not so sharp, but somewhere around here, so that when my components reach 80 degrees, the fans will be running full bore. Obviously, this is quite a drastic example, but a few more edge cases, if you have a dot all the way at the end of your graph, and you'd like to lower the max temperature, for example, to 60, you wouldn't be able to do that until you move your final point left. Then you can adjust the graph's dimensions. On top of this, to make a drastic jump, for example, such as this one over here, from 30 degrees at 30% to anything below this at 0, we can add a second dot, and you'll see that it's at 29.9. To make a pretty much straight line, just make sure that the number is about 0.1 less. Anyways, super advanced. Mainly, for the most part, you'll find out where your fans are noisy and adjust this to be some kind of smooth curve or gradient like this. That's it. Once we've adjusted our graph, we can start controlling fans by selecting the curve just like this, and these fans will react to whatever the GPU temperature is, for example, based on this curve here. You can add as many fans or control as many fans as you want from any graph or setting. Let's get a bit more advanced. I'll hit the plus, and we can add maybe another graph for my CPU. We'll just name this one GPU. Alright, so temperature source, CPU max, and we'll make some kind of a curve here. There we go. That seems pretty good. Let's combine these. So, based on whatever is hotter, whether it's my CPU or GPU, the case fans should ramp up. For this, we can add a mix fan curve, then choose a function such as the maximum of multiple temperature sensors, sum, average, min, and subtract. I'll go with maybe maximum. Then both GPU and, we'll add another one, CPU. Based on whichever temperature is hotter, that's the percentage that we'll use. So in this case, my GPU is a bit hotter, so the fan should be running a bit faster, and my CPU is cooler, but they can benefit from the free cooling of ramping up my other case fans. Then we can select the mix, and just like that, our fan should react to the maximum temperature of our CPU or GPU. You can add a trigger curve and choose maybe my CPU, so that the idle fan speed will be maybe 30%, as that's dead quiet for me, and the load fan speed will be about, 85%. It'll idle at anything below, let's say 40 degrees Celsius, and as soon as it gets up hotter than maybe 50 degrees Celsius, the fans will spin up. So currently at, let's make it 55, it should be idling, as it hasn't yet crossed the barrier to reach a load. This way, it'll be running at 30%. This graph will essentially look something like at 55 degrees, 80%, and at 40 degrees, it'll be 30%. It'll look something like this. This middle piece over here is more like a trigger. It'll run at the idle speed all the way up until it reaches 55 degrees, where it'll jump to 80%. And when it's coming back down, the graph will look more like this. It'll keep running under load all the way until it reaches idle temperatures, where it'll drop back down. That's the trigger function over here. Deleting this, we can add another one. Let's go with maybe sync. This option allows us to choose multiple controls. So maybe my back fan is controlled by my motherboard or something else, and I'd like to sync another fan to it. Simply by doing this, it'll read the fan's speed. Then we can either offset it to make it faster faster or slower than whatever other fan we're monitoring, and set another fan to match that, either at the same speed, faster or slower, and they'll adjust together. Finally, the beta fan curve is one of the more simple ones, even though it looks a bit more difficult. I'll choose a temperature source, so maybe my CPU maximum temperature core. Then we can change some numbers here, so it'll idle at anything below 40 degrees, and as soon as it hits maybe 60 degrees, the fans will kick up to 80%, and they'll be 30% at idle. The step is a new option here that allows us to change how fast it raises or drops as soon as one of these trigger temperatures is hit. The lower the step, the slower the fans will either ramp up or ramp down. But this is a bit more confusing, and I much more prefer a manual graph, even though an automatic one is pretty good. Let's say that our fans are speeding up a bit too quickly, or they're dropping down a bit too quickly. So your computer is slowly heating up. It reaches here and it jumps up. Suddenly the fans are 100%, then they're back down to 50 and up and down way too quickly. What can we do? Well, we can change the hysteresis and response time up here. If the temperature doesn't change by more than 2 degrees over maybe 2 seconds, the fan speed won't change at all. Or maybe a 5-degree difference is completely ignored if it's not changing faster than 2 seconds. Obviously, this isn't the best. Usually, you'll leave the hysteresis 2 and the response time at 2 or maybe even 1 for faster responding fans. You can choose to only get this to apply to fan speed on the way down, but to make things a bit simpler, we can actually expand each fan control and choose how fast it ramps up and ramps down. So you'll want usually a really fast speed up where the fans max out as soon as your CPU hits 90 degrees or something under a stress test or demanding situation, and the fans will slowly ramp down instead of suddenly so that it can cool down more reliably, and on top of that, it won't have such a noise disturbance of speeding up and slowing down really quickly. You can set a start percentage and stop percentage. These are automatically set, so you don't really need to worry about them. And finally, offset. If one fan is running faster for some reason compared to other ones, these are all the same fan, so they should be running at the same speed as they have the same percentage, but this one over here is a little bit faster. We can change this using the offset percentage here to slow it down to more accurately match other fans in our system. Just as an example, we can also set a minimum fan speed, for example, of 30, so our graph will look something a bit more like this, even if the actual graph goes lower than this. Anyways, that's pretty much it for the control section and sensor section. You can choose to hit the 3 dots and hide either controls, sensors, etc. Then the eye in the top right, followed by unticking show hidden cards. This way you can pretty it up quite a lot. You can also enable columns mode to have things stacked vertically if you so wish. And of course showing the fan speed cards over here, which literally just show the fan speeds. That's it. On the theme tab, we can adjust how the program looks in real time just by dragging these dots around, and you can see how the colors change. We can control each one over here as well on the side just to further customize how the program looks. Super controllable. On the icons tray section, we can control the icon on our start bar. By expanding this over here, you'll see the fan control system here. We can right click and open this or choose configurations to quickly swap between different options such as maybe silent or loud modes. Then settings, start minimized, log on, etc. I'll usually set the login delay to 1 second, which is the lowest. That way it'll start up as soon as our system boots and logs in, just so the fans aren't running a lot faster if your motherboard is configured that way. Sensors, we can edit this to customize what we had at the very start, add custom nicknames to different sensors, for example, and finally, load plugins. But this is more advanced. Finally, the About section, we can learn about it and visit the official website. If we do that, we can find lots of information about the program, and on the dock section, learn more about it, as well as how to more finely control, etc. There's even a command line section down here. Let's talk plugins. If we visit the GitHub page over here, scrolling down, you'll find plugins where we have all of these different controls here, such as thermal take fan controls, liquid CTL, ASUS, high flow next, etc., etc. These are all different controls for different fans and systems, even if they currently don't work well with your system or aren't that controllable, etc. These are all set out to try and fix different issues and control different devices. For the most part, that's it. We've now completed going through this entire system, and we can greatly control the fan speeds to keep our system cooler and of course quieter. If you crave a system that's even quieter after optimizing your different curves, etc., something you can look into is undervolting and underclocking. Essentially, you remove some voltage from your CPU, GPU, etc. That way it runs cooler, as more power means more heat. But on top of this, as we're removing some power and removing some heat, sometimes a lot of heat, you can actually let different components boost for longer, meaning that you actually improve the speed of your system by removing some power and of course lots of heat. If I close this and instead load up my actual fan configuration, you can see that I have super gentle curves set up with this very long section over here between, quite literally, not making a single noise and starting to hear the fan noise here, where it ramps up very quickly to 100% at 85 degrees Celsius. This way, my PC is practically dead quiet. Quite literally, all that I can hear with these Noctua fans are the hard drive spinning and possibly an AIO pump if that's quite whiny or noisy, and everything is completely silent all the way up till it reaches about maybe 60 or 70-ish degrees, which is perfectly fine for most components. Keep in mind that temperatures are all based on what you want. The cooler a component is, the longer it lasts. But some Intel or AMD processors of certain generations are designed to run hotter as they require more voltage to run faster, etc. Undervolting can help you seriously here, but that's a video for another time. These are my graphs over here. If you'd like to look at them or copy them or whatever, essentially I've got my CPU temperature, GPU, and motherboard. Then I pick the maximum of whichever one is the hottest, then control the back fan, front fan, and bottom fans just to move more air through the case. Then, based on what my CPU is reaching, the radiator kicks up here. This could also be controlled by the maximum, but I'd prefer to have this set to just my CPU alone, so if that's a little bit cooler, it's just a tiny bit quieter. But anyways, this could be set to the max, etc. I could use averages, but one thing you will notice is that I'm not controlling my fan speeds of my graphics card. Why is this? Well, simply put, I use MSI Afterburner where I raise the power limit, slightly underclock the core and memory here, and you can set up a user-defined fan curve or fan speed in the settings followed by fan. If I enable this and set up a custom curve, I'll have two different pieces of software fighting for each other, but for the most part, the default fan curve is pretty quiet on the 3080 Ti that I have, so I'm just leaving it as is, off here and off in Afterburner, so that the component just controls itself. If we were to turn off the front fans here, for example, it's not that they wouldn't be controlled at all, or they wouldn't be turned off at all. Instead, it defaults back to the default curve from our motherboard and whatever you have set in the BIOS. On top of this, once you've found a nice fan curve that works for you, you can instead edit this and copy something similar to your BIOS so that it's controlled via hardware and BIOS instead of just software in Windows. Anyways, this video's gone on for more than long enough, and you now know how to control fan control completely from start to finish. Hopefully you found this in-depth guide super useful. Thank you all for watching. My name's been Troubleshoot, and I'll see you all next time. Ciao.